in Indicator 9. And we will be quizzing tomorrow, so make sure that if you have any questions that you definitely reach out. So for our notes today, we're going to be looking at graphs and making some assumptions. So the one thing that we need to clarify, whenever we are talking about rates, I know I said this yesterday, but I can't stress it enough. When we're talking about rates, we are talking about slope. So faster rates or higher rates, they will be steeper lines. So on this first graph, we are comparing the distance traveled in miles compared to the time in minutes that we're traveling. So if we can see here the distance we traveled, we're starting out at 0. That means we haven't traveled anywhere. And then over time, we are increasing from point A, or from the start all the way to segment D. We are changing some speeds as we go through. And so if we look here, we're comparing, and we might not necessarily have to do these in order. So whenever we're looking at these, we want to see which segment is walking, which one is running, which one is resting, and which one is jogging. So the first one that I want to talk about is resting. So if you are resting, that means that there is no movement. So if you are resting, which line segment has no change in distance? And that would be segment C, because it is the one that right here we are not moving anywhere, so that's no change. Now the other three we have to compare based on steepness. So we have to see, we have walking, running, and jogging. Walking is definitely going to be the slowest out of the three movements. Running will be the fastest, and then jogging is just kind of in the middle. So if we look at this, so this is our resting moment. So if we want to decide running is the fastest. So if we look at all three of these line segments that are left, we have segment A increasing, segment B, and segment D. The one that is increasing the most, or is the steepest, is segment B. So that one would be our example of running. Now walking and jogging, if we are looking at this, this one is a little bit more challenging to do, but you're just comparing, and it not as easy to tell the slope between those two. We can calculate if you like, but if you just wanted to eyeball it, we're definitely probably going to say that the segment A is a little bit steeper than segment D. So we're going to say segment A is the jog and segment D is the walk, and segment B is the run. Now if we wanted to really compare those two, the one that I marked jogging, the slope, if I do rise over, it goes up 2 over 3. So segment A, the slope is 2 over 3, which is 0.66666. It's 6 repeating. All right, now segment D, it's only going up a half, but it's going over 2. So for segment B, the slope is 1/2 over 2, which is 0.25. So if you see that, 1/2 over 2, half of a half is a fourth, or 0.25. So whenever you look at it numbers-wise, we can definitely see that slope A is steeper than slope D. But whenever you're just eyeballing it, and they're not measured in the same units, sometimes it is a little tricky. But if you want to count your slopes, you're more than welcome to. You can see the slope of B is up to 3 over 2, and I should have said D, not B. The slope of B is 3 over 2, which is 1.5, so that's pretty large, and then the slope of C is 0 because we didn't rise at all. So the main thing from example 1, we just want you to know that faster rates will have bigger slopes or steeper lines, larger slopes. All right, so we want to look at question 2. So let me move my page down. All right, so this time we are comparing speed and time, not distance. So we are comparing speed. So whenever we have an increase in a line, that means an increase in speed. Now here our speed is staying at 40 miles an hour. So it says what's happening in segment B. It starts at 40 miles an hour and it stays at 40 miles an hour all the way over for this. So we can say in this situation, oh, and it's counting by 15s, right? So we would say it's 40 miles per hour, because that's our measurement here, miles per hour, 40 miles per hour, and it's 1, 2, 3, 4, 45 minutes. And the reason why it's 45 is because halfway here would be 15 minutes, then 30, then 45. So it started at 15 and ended at 60, so that's 45 minutes. All right, in segment D, we're down here at 0. Now this is just one little unit, so that's 15 minutes. So we are stopped, or you could say 0 miles per hour for 15 minutes. Oh, I went out of order. That's okay. All right, next example, segment E. All right, this is an increase of speed. So we increase speed from 0 miles per hour to, how fast did we end up going? 60 miles per hour. In how much time? 30 minutes. Started at 90, ended at 120. So over that 30-minute period, we're just gradually increasing our speed as we travel. All right, segment F. All right, do we have a change in speed? Not at all. We're staying at 60 miles an hour for 2 segments, so those are each 15. So we're going from 120 to 150. So we are doing 60 miles per hour for 30 minutes. And then in segment C, we started out at 40 going down to 0. So this one, our speed is decreasing. Decrease speed from 40 miles per hour was the start of segment C, all the way down to 0. And how long did it take us? It's one segment wide, so in between 60 and 90 would be 75, so 15 minutes. And there we have it. So you just have to read your axis. On that last one, we were talking about distance. This one, we're talking about speed. So how fast? So whenever we're talking about speed, 0 here at the bottom, when you are on the line, that means you're stopped. When you're up here, it means you're traveling. It's almost like in segment B, it's like, I don't know, some of you probably don't drive, but it's like hitting the cruise control where you just, you're driving down the road and you hit that cruise control and you're just staying at that same speed all the way through. And then, segment A, we're hitting the gas. B, we're hitting the cruise control. Segment C, we're laying off the gas a little bit, maybe stopping to get gas or do something like that. Take a little 15-minute stretch break, go to the restroom. And then we get back on the road, we increase our speed again, we go up to 60 this time, our speed limit must have gotten a little better. And then we hit that cruise control again for a little bit, and then we know our journey's coming to an end, and so we slow down. And so this is telling us the fastest we traveled was 60 miles an hour on this trip. Now the trip was 180 minutes, or 3 hours, depending on how you want to evaluate that. So you could give a lot of descriptions for this graph. You could make up stories, like an example of going 40 miles an hour. Maybe, I don't know, you're going through a town on the highway, and then in here you're just like on the open road. So like an area where I can think that you have to slow down, like when you're driving on 41, it's like if you're driving to Terre Haute, you go through, which I know we wouldn't drive a 3-hour trip to go to Terre Haute, but if we had a different time frame, like it's like you're driving, you increase your speed, and then you get to Shelburne, and then you slow down, and then maybe like you stop at the gas station and get something, and then you speed up again, you start to hit your speed, and then you're going, and then it's here, and then you gotta slow down, hit your cruise control, especially like when you get out of Farmersburg, and you can really increase that speed, and then like once you hit like Ivy Tech, Menards, and all that stuff, you gotta slow down a little bit, and maybe you reach your destination. That could just be a fun way to describe that graph. All right, so I do have a couple more examples here. Let me get them all straight. All right, so we're walking to a friend's house. All right, so this time we're going back to comparing distance. This one is comparing distance from home. So at 0, if I am 0 miles from my house, on this line here, I am at home. Then the farther away I get from this line, the farther away I'm going to a friend's house. All right, so if you wanted to write a scenario for this, so we have to, every time you have a change in your line, you need to have a description. And since we have 2 labels, we have distance and we have time. In each part, we are going to have a distance and a time. So for segment A, is going to be my first sentence. All right, how far did I travel? I started at 0 and I went all the way up to 60 miles. So in that segment, I travel, or this, we're talking about Eric, so we would say Eric traveled 60 miles in 2 hours. All right, so he stays 60 miles away. So he's traveling, and then he has a flat line where his distance doesn't change. So what this is meaning here is he's not moving. He's staying 60 miles away from his house. So this is probably a point in time where he stops to visit his friend. So then we would say he then visits at his friend's house for, how long was he there? From hour 2 to hour 6. So the length of this here is 4 hours. So he was at his friend's house for 4 hours. And then after the visit, so this time he's 60 miles away, but then over time, he's starting to head back, and he ends up at 0 miles from his house, so he ends up back home. So after the visit, he travels 60 miles in 2 hours back to his home. So we want to include, he didn't get farther away from home. If you traveled farther away from home, it would have went this way. I'm going to draw that in even though it's not correct. So this would be going farther away from the house. This one's going back to the house, so it's sending back down. All right, and then our very last example, we are dealing with distance from school, kind of like the one we did yesterday in our notes, in our time. So the rate for each runner. All right, so let's see, runner A is this example here. So, and if you guys want, you're more than welcome. For runner A, you can see 1 point on runner A's line is 0, 0, and the second point is 2, 2. So then you can simply just count slope. You could do the slope formula, and we would get 1. So on this, you could do the slope formula, and our time is miles per hour, so we could say 1 mile per hour. Now, if you want to just count, you can say, oh, well, you traveled 2 miles in 2 hours, and then say, oh, that's 1. 2 divided by 2 is 1. All right, then For B, its starting point is 0, 1, and then it crosses at 2, 2. So this slope would be 2 minus 1 over 2 minus 0. And we get 1/2. 1/2 mile per hour. So if you half a mile per hour, that's definitely some slow running, but it's just hypothetical measurements. All right, so the y-intercept for runner B. Runner B does not start at 0. On our y-axis, we're measuring the distance from the school. So if this starts at 1, and we would say that runner B starts 1 mile from school. All right, and the question, what time will the runners meet? So when they meet, what is the time? 2 hours. So I have some more examples for you guys to attempt today, and I cannot hesitate enough if you guys have questions, ask. Asking questions are so important, and if you need to do a Google Meet, we can do that, and just reach out to me by email, or you can call the school, but email is honestly the best, because even if I'm not in my classroom, I have my phone on me, which has my school email. So I hope you guys have a great day, and I'll hear from you soon.